Okay, an application problem with inverses. Given the volume of a cube is a function of its length, side x, find an expression for the volume as a function of the side x. And then we're going to change gears for part B and find the where we let x now be the volume instead of the side. See, up here the side was equal to the x. But down here, we have x equal to the volume. And find the expression for the length of the side as a function of the volume. So S of x. We're looking for V of x for part A. The volume as a function of x, where x is equal to the side length. And for part B, we're finding S of x. That's the side as a function of the volume because we let now the x be the volume. Well, let's start with a cute little picture of a cube. The thing about cubes, which makes them so nice, is the sides are all the same. The length, the width, they're all the same. And even the depth. This is a depth. Okay. So this is a distance s going back to the back portion of the cube. So we know volume, V, for a cube is going to be equal to S times S times S. This is just a general observation. We're not calling the side, the length of the side, S. In part A, they told us to call it X. So let's answer the question using volume as X times X times X. The volume is a function of the side X. It's X times X times X because the volume of a cube is a function of the side, X times X times X. And we'll just simplify 3 factors of x as x cubed. There's our first answer. The volume expressed as a function of x where x is the side. Now we're going to do part B, which is more difficult. We're now calling x the volume, and we're going to find S of x, the side, as a function of the volume x. So we're going to start with this equation here, V equals x cubed. But instead of calling it V of x, we'll call it y equals x cubed. Now, we're going to do the steps required to find the inverse function of this V of x. We're going to find the inverse function. So we're going to solve for x. I just turned it backwards in this step, and then I got rid of the third power by taking the cube root of both sides. And remember, you only have to take the positive cube root. You only have to worry about plus or minus when you're doing an even index root. Okay, so x is equal to the cube root of y. Next step, number 3, is to rename the x's and y's. So x becomes y and y becomes x. Y equals the cube root of x. And since the x's are faithful, wait a minute, how do we know that? Well, just look at it. Anytime you plug an x in here, you're going to take the cube root, not plus or minus the cube root, just the cube root. You're going to get one answer for y equals for every single x that you put in there. Okay, so the x's are faithful in this new function, so we can replace y with its fancy function close. Well, the original function we started with up here was called v of x, so the fancy function close will be v inverse of x. Now, that's perfect. Everything's done here is perfect, but the question, part B, was, let's scroll up, is now we're going to let x be the volume. Okay, so you should think of x as a volume, and what we're looking for is the side as a function of the volume. So since the volume is represented by x, we can rename v inverse as the side as a function of the volume x. And then all we do is take this function and replace v inverse with s, and we get s of x, the side as a function of the volume, equals the cube root of x. So whatever the volume is, you plug it in here, take the cube root, and you'll know the length of the sides of each side. That's it.